So I'm going to explain simulation of floor ceiling fan, rotating ceiling fan. So this is the fan I have created. So almost similar to the ceiling fan I have tried. So different incident angle with the flap. Then I have created the crown, that is 3 blades in the center head, like that I have created. So for that I am going to create. So normally for the room you can take it as a square domain, or now I will take it as a circular domain, cylindrical domain, so that I will explain you the boundary condition. If it is a ceiling fan or the same thing, instead of fan, if you are using for the propeller or helicopter blade, anything, if you try, mostly you take the cylindrical domain. So I will go for the cylindrical domain. Otherwise, normally for the room with a ceiling fan means they will take a square or rectangular domain. So here I am going to take the cylindrical domain. So this is the CAD design. So I am using ANSYS Workbench. So in that I am going for the ANSYS Fluent Flow. So first let me import the fan model. So import this 3D fan model. Then rightly go to the design modeler to create the cylindrical domain. So I have to create 2 domains. One is closer to the model, which will be a rotating domain. Another one will be a bigger cylindrical domain, which is simulating the room or atmosphere, like that. So first step is to generate, so that you can get the model inside. This is the model. So let me create the profile in the X and Y plane. Okay, so I'm selecting X and Y plane, then go to sketch, select the sketch. In the sketching, here I'm taking the square circle. If you want, you go for the, that is inside domain. Rotating domain should be the circular one. Outer only depends upon the application, it can be square or circle. So inside one first I am drawing, so this should be the circle. So you can give the proper dimension, etc. and all. Just now I am randomly creating it. So first generate, so design is made. So go to modeling, you can do extrude. So let me change the view. So the circular is here, circular profile, the yellow color line. So extrude with the add frozen, then only you can get all the domains individually. Add frozen, then direction I am taking symmetric or asymmetric, whichever you want. So symmetric means both sides same distance, asymmetric I can control. So let me check 0.05, 0.05. Okay. So as I am giving equal value, you can go for the symmetric itself. Just one value is sufficient. So this is my first domain. Let me create. So inner domain is created. Same procedure I am going to create the outer domain also. Same XY plane, then sketch. Sketch 2 is created. Go to sketching. Here you change the view to XY. Now here only, if it is propeller, helicopter, etc. and all, you will go for the circular domain. If it is fan, you will go for the square also. So here I am taking the circular outer domain as an example. So you later control the dimensions. Just randomly I am drawing the circular dia. Generate, go to modeling, again extrude. Just let me change the view. So this is the original view. So I will take some less height in the top and more cylindrical length in the bottom. So here also I am taking add frozen. Then in the direction, instead of normal I am taking asymmetrical. And on side first let me give 0.3. Let me check where it is going. Okay, top one it is going. So let me take some 0.5 or 1 maybe. So 1 meter in the top, maybe 4 to 5 meter in the bottom we will give. So like this it is created. If you only can reduce a little bit. Okay, like that I am taking. Just for example I have taken, depends upon your simulation domain etc. You have to adjust this value. So 2 domains are created. Then I have to do boolean. So this is my fan model, and this is the inner solid, this is the outer solid. But I will change all the solid to there also you can change it. Here itself I will change everything into a fluid. Okay, everything is a fluid, and this will be my rotating. Okay, let me do first boolean, then we can define the naming, not an issue. So I'm going to do boolean. So 2 times I have to do the boolean. One is to separate this rotating domain from the outer domain. Then second one is to remove the fan from this inner one, like that. 2 times boolean I have to try. So first time I am taking the boolean. This time I may subtract, that is, so subtract the, so that outer domain is my target body and the inner domain is my tool body. I am going to subtract. I have to keep that model. Just I need to be separate that one, so it should not be deleted. So we have to preserve that model. So first time I have done the boolean. Okay. Then second boolean is to remove the blade. So second time boolean. But to remove the blade, instead of subtract, I am going to use this intersect, because if I use subtract, I am getting a lot of unnecessary phases, which I have to do a lot of simplification, cleaning of the body, etc. and all. So I prefer whenever you remove the object, you can go for this intersect. So go for intersect. So I am going to intersect this inner body and this model. Apply. Let me keep the model with the sliced, that is model is sliced from that domain. With that you generate. Now you see you have 3 objects. Okay, so the top is the the bottom is the fan. Okay, we sliced it from it, and this is the outer domain, and this is the inner rotating domain. So now I don't want this fan, so I am going to suppress it. Now I got final 2 domains. This is the, let me rename it, rotating fluid domain. And this will be my stationary fluid domain. Like that I have the 2 domains. So finally I created the domain required for the simulation. Then I can give the naming. For example, let me take just a wall everywhere now. Later, for example, if it is fan, so if it is fan, what normally I will give this top wall as a wall, and actually everything, the circular one also as a wall, bottom also as a wall. That is a closed room I will give if it is a just a ceiling fan simulation. Instead, if it is a propeller, then I will give this as the inlet, bottom as the outlet. This may be the far field, like that I will give. Propeller means. Or if it is a helicopter blade just starting, then I may give this is the outlet, the surrounding is the outlet. Top one can be just some inlet. In the bottom can be the flat ground. Okay, if the helicopter blade just starting means, okay, there will be ground of it. So bottom is ground, the surrounding cylindrical portion is the outlet, and top one will be inlet. Or at some altitude, if you are checking the helicopter blade means, it can be taken like small inlet, that is inlet in the top, the circular portion, and the bottom one can be the outlet. So that flow just it will leave. Like that, depends upon the application, you can change it. So here any one condition you will take it. Or maybe first I will go for the fan blade itself. Fan means everything should be closed. That way first I will simulate. If you want, I will show you like a helicopter blade also. That is here outlet, this is inlet, in the bottom ground, or can be outlet also. That case we may simulate. So first I have to name it. So this is a just outer wall I will give. Generate. Then top one, it can be inlet or it can be a wall also, that you will change it later. So now I'm taking this as wall, and outer one, it can be again stationary wall, or it can be an outlet, anything we can define. Okay, just for understanding I will name it like that. I may name this as, first I have to generate. Okay, so this one first I will take it as outlet. Okay, later I will change it, depends upon the application. So I have taken top is inlet, bottom is outlet, remaining is wall. So if it is a fan simulation, I am going to change all three as a wall. Okay, if it is a helicopter, I may change, that is at a particular altitude, means I can change, that is this will be, top will be inlet only, bottom will be the outlet, the outer wall also will be outlet. Like that I will change it. That we will do it in the next step. That's it. So now geometry is created. I can close it. Next we will go for the mesh generation. Mesh I am going to take just a very coarse only. You try a very refinement. So model is imported. Let me just generate to see the default mesh. So this is the default mesh, it is generated. Maybe I will refine little on the blade around. So I can go for insert. If you want, you can give face meshing also. Actually in the naming I think I forgot to give the name for the blade, right? So we will give it here. Maybe first I will finish the naming for the blade. So I will go for the, let me first hide this outer wall, hide this face, and this also I will hide it so that I can select the blade properly. Hide the face, this also. Now the blades can be selected easily. So I will go for the box selection, select only the blade, then right click, create name. This will be the fan blade or fan, simply I will give it. Okay, so fan also now it is created. This I should have done in the previous step itself. So you can show all hidden faces now. Okay, so let me refine the mesh now. If you want, you can give face meshing also on the blade. Already I have given the name right, so if you want, you can go for the named selection, and fan also straight away you can create it. Update. Then I can refine it further. Now also first let me refine the fan. Other thing also we can refine, but let me focus on only this fan first. For example 0.01, let me take how it is coming, let's see. A little bit refinement I will include further, maybe 0.05. Okay, it is refined. Normally we will give further inflation layer on it, and we need further refinement also in it. but just for this simulation I will leave it with that. Okay, face meshing, it is not enabled now. It may come properly if you give if you refine both this inner domain, airfoil, everything, fan, etc. If you refine further, this will be activated. Okay, now it is not necessary. Let me suppress it. Okay, so with that I will go for the next simulation. Just update before going to the setup. Okay, so you have to further refine this rotating domain, also this outer domain. Okay, then go to setup. So you will change, it depends upon the core, double precision, etc. You can start. That depends upon the system. We have to follow it. You cannot take the same 12 or something. So this is the imported domain for the simulation. Let me hide this wall, shadow, etc. and all. So now fan is here. You can change the view. Okay, let it come. So fan is here, inlet, outlet. This is the wall that I have taken. So first step, already I have changed everything into a fluid. Otherwise you have to change here. If it is solid, then manually you change this stationary fluid, rotating fluid, both as a fluid. Okay, you have to change it. Then simply I am going to change this rotating fluid domain. So I am going to give mesh motion, frame motion. Assume the fan is rotating with 300 rpm in radians per second. It is around 30 I am taking, and depends upon the direction you have to give positive or negative. So let me try 30 minus 30 because it is, I think, clockwise. So normally in the here clockwise angle of attack and all I used to give negative. So here also I think clockwise means negative I am giving. So close it. That's it. And boundary condition, if you want you can leave it as okay. You will change everything as wall. So there is no outlet. That is also a wall. Just a stationary wall. There is no inlet. That is also a stationary wall, so that you can simulate closed room condition. Okay, so I have changed everything into a wall now. Now if you are finding what is that, helicopter blade, propeller, then on that if you are finding forces, etc. and all, then in the reference value you have to give what is the fan area, what is the length, etc. You have to define it. So let me go for the standard initialization from fan, initialize, then run, maybe 1000 iteration, calculate, yeah, okay, just in the middle of the simulation I just stopped to check the results. So if you want you can find the forces acting on the blade, that is helicopter or propeller, means thrust, etc. you can find it. Here I will just show you how to find the contour, streamline pattern, etc. and all. So contour, so just double click. We can see the pressure on the model, on the fan, how pressure varied you can see. So this is the top view. You see, so if you want, you can rotate. So flow got accelerated in the leading edge, also in this curvature here slant. Okay, that's why there is a low pressure region in these two corners. So pressure you can check it, or velocity you can find. So velocity will be high near the tip and it will reduce towards the root section. Okay, so radial velocity is high near the tip, so it is a velocity variation. And if you want, you can find the pressure distribution etc. at a particular plane also. Okay, so normally we will find the pressure distribution on the fan, on the blades. Then let me show you how to find the streamline pattern. So go to the path lines. Instead of steps 500, which takes so much lines and time, I'm taking 50 steps. If you want, you can skip 1, 2 also. 10, for example, 10. Let me skip. And let me check velocity, pressure, everything on the first blade. Okay, on the blade I'm checking. So this how on the blade the pressure varied. Okay, there is, don't skip it, so that you can see properly on the lines. Okay, so see this how on the blade streamline with the pressure control looks. You can see in the tips there is a wing tip vortices. Here there is a more angle, so much pressure different. So there is a formation of wing tip vortex and trailing flows you can see. So this is for the one blade pressure distribution. Instead of pressure, you can check the velocity. Okay, so velocity is high in that portion on the tip vortices, like that. Velocity, pressure, etc. near the on the wing you can find, or at a different cut section also you can see. For example, I am going to create one plane. So that plane, see for example, it is showing where the position of the plane. So x is 0 or at particular distance, or any other plane also. Here it is YZ plane, vertical plane. You can change the plane also. Like that you can create a plane wherever you want to create. So I am creating the plane 8, 9, etc. and all. So 9. Also if I display, so now I will get pattern on the airfoil, also on the vertical plane. Okay, here it is coming in the different orientation. The beginning itself, you can, if you want, you can change the orientation. So this is the velocity profile. Just I have stopped in between. Actually I have to refine the mesh, also I have to run a little more, so that you will get different velocities in this streamline also. So otherwise, unselect the fan. Now you try, you can see only the flow pattern. So near the fan there is acceleration. Remaining also, if I run, I will get different velocities in the bottom also. So this is for the velocity. We can find other properties also. Okay, turbulent kinetic energy, etc. So the plane, whichever the this is vertical plane. If you want horizontally also, you can see the plane. On that plane, how velocity rate, etc. you can find. But now I just stopped in between. Now if I run at any horizontal plane, if you create, for example, on the floor at maybe 20% of the height, 50% of the height, and all, if you see, you can get different velocity contours, velocity, pressure, bit varied, you can find it if it is fully run. And here I have taken everything as a wall, top also wall, bottom also wall, side also wall. That's why the flow is confined within this boundary. Instead, if you give anything as outlet, etc. and all, the profile will vary. If you want that also, I will show you. So in the boundary condition, for example, I am taking inlet as the velocity inlet, just some minimum velocity value I will give it, like a far field. So velocity inlet I have given, and remaining and all wall you can keep, otherwise I will keep that outer wall as a outlet, pressure outlet, so that flow comes. Okay, so the condition now I have given may be similar to the helicopter blade which is near the ground. So this is my inlet, flow will come and escape through the wall, but there will be a bottom flow comes through the inlet, escapes through the outlet, like that I have given, but bottom I am keeping that as a wall only, outlet as a wall only. Okay, flow will hit on the wall and it will reflect. Or if you give this bottom wall also as outlet, means just the flow will go straight. If you want, these two cases I will show. As of now I have taken inlet from the top and leaves in the sides. Bottom there is a wall, like that I have taken. Maybe let me run, you will see. So with that condition, now if you try that streamline pattern, on this plane, maybe velocity just 50 steps. If you display, now you see flow enters here and leaves in the sides. Okay, there is a small vortexes formed, but flow enters from the top, leaves in the sides. In the bottom there is a ground, that's why flow hits and turned to the sides. Instead, that also if we keep it as a outlet, which is to simulate helicopter blade at an altitude, then there may be a flow only in the just below the fan alone. It may not divert like that. If you want, that also we can see. So in the boundary condition, I have to keep this outlet also as a pressure outlet. So I have given top as the inlet, then surrounding wall also as the pressure outlet, the bottom also as a pressure outlet. Now let's see how it changes. So just after a few run, let's see how it comes for the just the inlet and everything as outlet. So on the plane 9, now if you display, now you see just the flow is, inlet is from the top and it is leaving on the side also in the bottom. Either you can, depends on the application, you can change the wall conditions, inlet conditions. That's it. See here I have created the plane in the XY plane, that is different horizontal planes I have created. For example, you see I am seeing the same streamline pattern at different horizontal planes. One is at the blade, one is just above the blade, another two below the blade, like that, just different planes I have created. There I have checked the velocity streamlines. You can see the streamlines, how it varies at every plane. This is on the blade, one is the above, then in the bottom two, how flows are related again, how it lays, etc. You can check it like that. You can create planes horizontally, vertically, everything you can check it. Okay. Yeah, that's it.